All right, hello and welcome. In this video, we are going to be talking about the different extrema of a function. So the word extrema might sound like, oh my goodness, like what are we doing here? But it's really just the minimum and maximum values of a function. And for now, we're just taking a look at a graph and trying to understand from the graph what are our extrema. So if we take a look here, I've just sketched this random curve. And I want to identify some of the minimum and maximum values. So I'm going to identify our extrema. Well, I always tell students whenever you're looking for an extrema, if you want to find a maximum, it occurs at the top of a hill. Okay, so right here, this point that I've marked in red, this is a maximum. All right, this is a maximum. And we can see because it's up above all the other points around it. Even though it's not the highest point of the entire graph, it's up higher than the point directly to the left and the point directly to the right of it. So that is known as a relative maximum, because it is the highest point out of all of the points in its immediate vicinity, but it's not the absolute highest point on the graph. We do have an absolute maximum of this graph, and it occurs somewhere over here. This is our absolute maximum. An absolute maximum, like I said, that means in the entire domain, it is the highest possible y value that we could ever get out. So sometimes absolute maxima will occur at the vertex of a parabola that opens down. For example, that is an absolute maximum. All right, and then our minima are going to occur at the bottom of a valley. All right, so very similar. This green point right here, well, that's at the very bottom of the value. That's when our function goes from a decreasing function up to an increasing function. All right, and so this here is a minimum. And in this case, that is a relative minimum because it is not the lowest point on the entire graph. Because these arrows point down, we know that they're going to go on down forever. So this is just a relative minimum. All right, this is a relative minimum because, yes, it is at the bottom of a valley and it's lower than all of the points around it. However, I could pick out an infinite number of points that have an x value that is actually more negative than that point, or a y value that's more negative than that point, excuse me. All right, so there's a couple of max and mins for us. And now let's identify our extrema on this graph. So on this graph, we see that something weird kind of happens right here. Okay, as we go up, it appears to flatten out and then just continues to increase. So say that a point is labeled right here. That point actually is not an extrema, okay? Because although it might flatten out, it continues to increase, so it's not higher than the points around it. So this right here is not an extrema. All right, not an extrema. The same goes for if a function goes from increasing to constant. Okay, if it flattens out completely, then none of those points are an extrema because they are not higher than the points immediately next to it. Okay, this point here is a maximum. We can see it's at the top of a hill. That is a maximum there. All right, and it's only a relative maximum because this arrow points up. So we know that there will be values higher, y values that are higher than that point right there. So this is a relative max. And then this point right here we can see is at the bottom of a valley. This arrow down here points down. We also have points right here with a lower y value. So this is just a relative minimum. So a relative min, again, it is lower than all the points in its immediate vicinity, but it is not the lowest point on the graph. All right, hope that this helped you guys out. Best of luck on the homework.